Hello everyone, my name is Johansson and my register number is URK25CS1018. So in this video I'm going to explain how to solve a partial differential equation or PDE using the method of direct integration, and I will be also showing how the same process is done using SimPy in Python. The given PDE is dou square z by dou y square is equal to 2y. This equation means that the second partial derivative of the function z with respect to the variable y is equal to 2y. Here z is not a normal single variable function. Instead, it depends on two variables x and y. So we write it as z is equal to z of x and y. In this Python program, first we import SimPy using import SimPy as sp, and then we declare the symbols x and y using x comma y is equal to sp dot symbols of x and y. After that, we declare z as a mathematical function using the z is equal to sp dot function of z, and this allows SimPy to understand that z is dependent on both x and y. Next, we define the PDE in Python using that sp.eq, where sp.diff of z of x comma y comma y comma 2 represents the partial derivative equation, meaning the second derivative with respect to y, and the right hand side is 2y. Now to solve the PDE, we apply direct integration. Since we are given the second derivative of z with respect to y, we first integrate the equation once with respect to y to reduce the order. So mathematically, dou z by dou y is equal to integrate of 2y comma dy. When we integrate 2y is with respect to y, we get y square. However, in PDE integration, the constant of integration is not just a simple constant, because we are integrating with respect to only one variable. So the integration constant may depend on the other variable x also. So this is why we add an arbitrary function f of x. So after first integration, we get dou z by dou y is equal to y square plus f of x. In the code, this step is done using dz underscore dy is equal to sp dot integrate. Then we integrate once more with respect to y to obtain the function z of x comma y. So we write z of x comma y is equal to integrate of y square plus fy in dot dy. Now the integrate of y square by dy is equal to y cube by 3. Also, since does not contain y, it behaves as constants. It begins a constant while integrating with respect to y. Again, because this is the second integration, we must include a second integration constant, and in PDEs this constant can also be a function of the other variable x. So we add g of x also. Therefore the final general solution becomes z of x comma y is equal to y cube by 3 plus y f of x plus g of x. In this code, this is represented using z underscore x er is equal to sp dot integrate of that function. Finally, SimPy prints the expression as the general solution of the given PDE. Here f of x and g of x are called arbitrary function, and they can be determined only if we are given additional information like boundary conditions or initial condition. So this is how we solve a PDE using direct integration step by step, both mathematically and using SimPy in Python. Thank you. So we will run this code. And you can see the output here.